Good afternoon, everybody. Welcome to today's webinar on pairwise testing using the ACTS or ACTS tool. I am Rex Black. I'm president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered confidence and insight to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. So today is a one key idea session. It'll be short and sweet. It's an abbreviated version of something longer that I gave a few years ago. If you're interested in that one, you can go look that up on the RBCS YouTube channel and give that a listen. But we're going to do the short and sweet version here in honor of the sniffly bats who brought us the spare time that we have at home. Let's start with the problem we're trying to solve and go from there, okay? So in a number of cases, we will have factors or variables that can take on different values or options. And I'm going to use the phrase factors and options going forward, just to be clear. But if you're more interested, more used to hearing about variables that take on values, and that's another way of thinking about it. So an example of this would be if you were looking at options for formatting a text in Microsoft Word, and you open that font menu, excuse me, and this would be true in other word processors as well. And you see, oh, well, there's things like superscript versus subscript and so forth. There's italicized, there's bold, there's underline. There's all sorts of different factors that can take on different options. And now, in standard testing theory, when you're looking at factors that can take on options that are supposed to be independent of each other, or unconstrained, what we would say is, well, we should test the equivalence partitions for those if they're not sorted or ordered. Sorted or ordered meaning that you can talk about one being greater than the other. If they are sorted or ordered, then you want to test boundary values, right? But that leaves out a possibility, which is what if they are interacting? What if they're supposed to be unconstrained, but there actually is some sort of undesirable interaction between them? So if you wanted to try a brute force approach to attack that, you'd be in big trouble really soon. So if you have 10 input fields on a screen, let's say, and there's 4 equivalence partitions for each input field. So the first can take on 4 different values, the second 4 different values, and so forth, all the way to the 10th. And I want to test all possible combinations. Now that's going to be 4 times 4 times 4, dot, 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 you know, all the way up. So it's basically going to be 4 to the 10th or 2 to the 11th power, which is 2048, if I remember right, which is a really big number. Okay, so as usual, brute force attempts to do exhaustive testing fail miserably. So you're sort of left going, well, now what am I supposed to do if I want to try to see if there's undesirable interaction between different options that can be assigned to particular factors? So there's a way of modeling this, and this is what pairwise techniques do for us. And they create a tabular representation of the factors and the combinations of options for each factor. And then what we do is we test row by row. So the tables are generated in such a way that each row corresponds to a test. Now, you might say, well, is this good enough? I mean, if we're just testing pairs, what about triples and quadruples and quintuples and so forth, higher order combinations? Well, it turns out there's a fair amount of research that's been done on this. And it's quite unusual for the higher order combinations to cause problems. Generally, if you're going to have some kind of issue, it's going to be either a particular option for a particular factor doesn't work, regardless of what the options that you selected for the other factors are. And that's a singleton, and equivalence partitioning will find that for you. And then a smaller but still sizable percentage of problems can occur when a factor can take on an option and another factor can take on an option, but if those two factors take on the exact wrong option, these two options for these two different factors that don't like each other, that will cause problems. So those are pairs of options, and the triples, quadruples, quintuples, and so forth tend to not be as big a cause of problems. Now, excuse me, there are papers, as I said, that will discuss this for you, and fortunately, these papers can be found at the same location as a nice free tool from the federal government, National Institute of Standards and Technologies, can be obtained. So I'm going to show you this tool a little bit later, and then point you in the direction of where to find that. And then if you want to get the theoretical justification for why this works, that can be found the same place you download the tool. But let's start by getting a little bit more clear. Now, we're gonna talk primarily, and I'm going to demonstrate primarily the use of a tool to solve these combinatorial problems. But the old school way of solving these problems was to use something called an orthogonal array. And an orthogonal array is just a mathematical construct where you're guaranteed that every possible pair of options across every possible pair of factors is going to occur at least once in a row in the table. In fact, the number of times that pair occurs is referred to as the strength of the table, and if the strength is 1, you're guaranteed that it will happen once. Now, there are orthogonal arrays that you can find and download from this website that you see here, york.ac.uk/deps/maths/tables/orthogonal.htm for those listening on podcast. I'm going to only use orthogonal arrays to demonstrate what the tools are doing first, and then I'm going to show you how to do this with a tool, because really what you want to do is use a tool. And what I'm going to demonstrate is a freeware tool called ACTS, as I said, and you can find a link to ACTS at www.pairwise.org as a good location to go find Pairwise tools. There's also a tool out there called PICT or PICT, which is available to download off of GitHub. I've used that one as well, and it's also a fairly useful tool. There are some theoretical differences with regard to an orthogonal array solution versus an all pairs table solution. As a general rule, when you're doing the kind of testing that we're going to look at here, that won't matter. So let's start just by demonstrating, just like really simple. If we were just thinking about orthogonal array, what is an orthogonal array? And this, I'm not explaining these because I want you to understand orthogonal arrays. I'm wanting you to understand what I mean by pairs of options across pairs of factors. So this is an orthogonal array. So remember, the orthogonal array is guaranteed to have every pair of possible options across every pair of factors. So this is a really simple orthogonal array because it only has two factors, 1 and 2, and each factor can take on two options, 0 and 1. So if we say what our first test would be is factor 1 taking on value 0, option 0, factor 2 taking on option 0. So 0, 0, that's test number 1. So 0, 1 is test number 2, 1, 0, test number 3, and 1, 1 is test number 4. Okay. Now you might say, my options may take on a 0 and 1. What would that look like? Well, that would be like clicked versus unclicked, true versus false, on versus off, right? Those are Boolean values that can take on a 0 or 1 value. So you might have those. And if you only have 2 of them, then, you know, here you are, and you're going to have 4 tests. And you might say, well, that doesn't help me at all because that's, 2 times 2 is 4. So that's all possible combinations. But take a look at this. Here's where the power of the pairwise techniques comes in. Let's suppose I have 3 Boolean factors, 1, 2, and 3. Again, each one can take on an option value of 0 or 1, on or off, true or false. Okay. And we still have 4 tests, even though we're up to 3 factors. So you might say, well, 2 to the third is 8. There's 8 possible combinations. And that's true. There are 8 possible combinations. But remember, we're not going down the brute force exhaustive testing primrose path, because that leads to madness and infinite tests. We're just trying to test the pairs. So we want to make sure that with the pairing of factor 1 with 2, the pairing of factor 1 with 3, and the pairing of factor 2 with 3, every possible pair of options is represented. So if you look at, and again, for podcast listeners, I apologize, it's going to be a little hard to visualize, but the first row in that orthogonal array contains 0, 0, 0, the second 0, 1, 1, the third 3, 1, the third row 1, 0, 1, and the fourth row 1, 1, 0. Now, if I go pair of factors by pair of factors, I'll go look at 1 and 2. So in the first row, I've got 0, 0, second row 0, 1, third row 1, 0, fourth row 1, 1. All possible pairs are there, see? Now what if I look at factor 1 with factor 3? So I'm just going to skip factor 2 in the middle there. First row again is 0, 0. Second row again is 0, 1. Now the 1, 0 value is in the fourth row, but it's still there. And the 1, 1 value is in the third row. See, all 4 possible pairs of options across the pairing of factor 1 with 3 are there. And then if I pair factors 2 and 3, 0, 0 is in row 1 again. 0, 1 is in row 3. 1, 0 is in row 4, and 1, 1 is in row 2. See how that works? They're all there. Okay? All the possible pairs of options across all possible pairs of factors are there. And as you continue to add more factors, the number of rows will generally not increase, or will increase only slightly. This is where the power of this technique comes in, and you will see that here shortly. Now, let's move to a slightly more complicated problem. Let's say that we wanted to test compatibility of the RBCS website. So we're going to look at a relatively slower Wi-Fi connection speed and a higher wired connection speed. So they've got 2 values for connection speed. So that's 2 options there. Okay. But for operating system, we have 4 possibilities: Mac, Linux, Windows 7, and Windows 10. And then for the security factor, we have 4 options: OS only, Symantec, Trend Micro, and McAfee. And for the browser, we have Chrome, Internet Explorer, and Opera. Okay, so 3 options. So this is where the orthogonal array technique gets a little cumbersome, because if I wanted to do this, I'd have to go out to that york.co.uk website and look for an array that had the right number of columns and the right number of numbers per column and the right number of rows, which, since 4 is the maximum number of options for any factor, it's generally going to be 4 squared, what that value is going to be. So I'd have to go find the orthogonal array, and then I would have to, it says AT&T site here. AT&T used to have orthogonal arrays available, but now you would get them off the York site. So what I would do is I download the orthogonal array, which is shown in the middle of the slide. You import that into Excel using the import wizard, which you tell it it's fixed columns and so forth. And you then add the test numbers on the left-hand side, and you add the factor names on the top of it, and then you change in the speed column 0 to be Wi-Fi and 1 to be wired, and then 2 and 3 to be the tildes, which represents tester's choice. It basically says you can choose either Wi-Fi or wired, whichever is more convenient to you. And then in the OS column, you'd substitute 0 or Mac for 0, Linux for 1, Windows 7 for 2, and Windows 10 for 3. And you'd get the column that you see for OS there. Security would be at 0 for just OS security, 1 for Symantec, 2 for Trend, Micro, 3 for McAfee. And then with the browsers, we have 3 options. So 0 is going to become Chrome, 1 becomes IE, 2 becomes Opera, and 3, since we don't have a 4th option for the browser, becomes tester's choice. And again, tester's choice means you just test with whatever you want. Okay, so this can be done, and it's, if you've done it enough times like I have, it's not tremendously difficult, but you know, it's still, it's work. And if the problem changes, like, oh wait, we want to now support you know, 2 different versions of Mac, say, or something like that, or we want to support Chromebook or something like that, then you have to do the whole exercise over again. You got to go out, find the orthogonal array, and map the problem onto it, and so forth. Sure, the orthogonal arrays are free, but wouldn't it be nice if there were free tools? Well, it is nice, isn't it? So it's nice to have free tools, and so there are a few out there, as I've said. And yes, I did cough into my sleeve there. I was practicing social distancing, even though you're all way away from me. So there are a number of free tools, as I said. PICT, that PICT tool, is one of them. Axe is another. Both of these are listed at the pairwise.org website. So let's take a look at the same problem that we just solved using the Axe tool, which you can find, again, at the Pairwise site, which will redirect you to the NIST.gov site. And if you search for the ACTS string on the NIST.gov site, it'll take you to the ACTS or Axe page, where you can not only ask for a copy of the tool, which will then be promptly emailed to you, you can also download the papers that I was talking about, which will explain why this is okay. Whoops. Okay, so let's get the tool up. Okay, so the tool is a executable jar file. So when you get it, that's what you get. You get an executable jar file along with some other supporting stuff, and it uses XML to store its data. And the solution that I get for the problem that we were just looking at, the RBCS web compatibility, looks like this. So again, we have 16 rows, the same as before. It's not quite identical. There are some differences in terms of which values are in which rows, but remember, it doesn't matter. What matters is not the value of any given row, it's the values of the pairs across the possible pairs of columns, and are they all represented? So let's look at just connection with OS. So we got wired with Mac, we got wired with Linux, we have wired with Windows 7, and we've got wired with Windows 10. Okay, those are there. And we've got Wi-Fi with Mac, and we've got Wi-Fi with Linux. We've got Wi-Fi with Windows 7, and we've got Wi-Fi with Windows 10. Sorry about the ringing phone in the background here. We are in the office today, and there's going to be some phone noise. So you can see that all possible pairs of options across the pair of factors connection with OS are represented in the table. And you can go through and satisfy yourself that that's true for any of the other pairs that you might want to look at, pairs of factors. And I say, okay, well, that's the solution. How did you get that? Well, what you have, oops, let's see, why is it doing that? I don't know why it's doing that. Hang on, put it in the wrong place. Here we go. Drag that over there. So what you can see is I set up these parameters, and the way that you do this is you add a parameter type and you define it. So I could set up another one. Let's go new param, let's say. Okay. And oops, I'm sorry, something weird just happened there. And then I can say, oh, well, oops, actually, I don't think I can have spaces in there. I think new param. Let's do it that way. And then I could choose to be an enumerated type. So enumerated type means that I assign specific values. Boolean means it's either true or false. It can be a number. It's another possibility. And then if numbers, I can select range values there, what the minimums and maximums are. You can see those shown there. And then they can be, no, sorry, range is where you can select the values. If you say number, it's unconstrained. So there's 4 different possible values for the parameters, 4 different values that they can take on, basically. And then you would just add that to the table. All right, now I'm going to cancel that because I don't actually want to do that. But let's see, modify it. Brought it up in the wrong place again. But okay, so basically I add each parameter and the parameter type and values and so forth. And then once I've made the changes, if I actually want to make changes, I would say modify system. And then notice that up here it says test set out of sync with system. So then what I would want to do is say build. It's supposed to happen. Oh, wait. It's popping up the window in the wrong place. So when I say build, it then brings up this options window here, which you can see. Again, apologies for those of you who are trying to follow along on a podcast here. It'd be easiest if you got the tool first and then gave this a shot. So I can say, okay, what is the strength of the table that I want? And that's strength 2 means pairs. I can say strength 1, which just means equivalence partitions. I can say strength 3, which means triples, so forth. Mode from scratch as opposed to extend the existing table. Constraint handling. There are different ways of handling constraints. I'll talk about that a little bit later, but we're not going to try to get into it. And then there are different algorithms. If you're interested, you can read about what the different algorithms do, but we're not going to get into those. The IPOG is their recommended algorithm. And I click go ahead and do it. Replace, and now we're back. Okay, and notice this one does look a little different. It this time it fully specified the values because I told it to randomize the don't care values. So I gave it, it got randomized values there. So that's a simple problem solved with this tool. Now let's move on to a somewhat more complicated problem here. Go into presentation mode just so this looks a little nicer. Because it might not be all that impressive to you when you think, well, you know, there's only four factors there and maximum 4 options per factor. So, you know, I mean, 16 tests, okay. I'm not that impressed. Well, let's suppose though that you were testing a mobile app, and what you're finding is that connectivity factors and the options that are assigned to those factors have a strong effect on it. Now, I've seen this myself. At one time, I had a podcast app that I used, which I no longer use, that podcast app would do very irritating things if connectivity status changed. It would like pause or skip ahead or go on mute for a while. It was really irritating. So it had some major issues with connectivity and how it would affect it. So you might want to do a test like this if you're testing a mobile app. In fact, I recommend that you do. So we look at like, okay, what are all the different connectivity factors? Let's say for this particular system we're looking at. We got Bluetooth, Wi-Fi connection, Wi-Fi frequency, Wi-Fi calling. So Wi-Fi calling being, well, let's switch a phone call to Wi-Fi if it needs to. Excuse me. As a near field communication, mobile data, and mobile connection options. Okay. So you notice that here, this is a pretty complicated. We got 2, 4, 7 factors and a number of different options per factor in some cases. So this could really kind of blow up in trying to attack this brute force. And let's also just put a pin in this for the moment. Let's assume that I'm particularly worried about the 3 Wi-Fi factors and that they might interact. So what I could do, again, going back over to get the tool up. Okay. Build a solution that looks like this. All right. So you see the factors there. Expand that out a little bit so it's too much scrolly stuff going on. It's a little scrolly stuff. And notice I was right. You can't have spaces in the factor names. You can use underscores. I think you can use dashes too, but maybe not. So I think a dash might have a special meaning in the Constraint Editor. So here's my solution, and it's got 28 rows. You might say, what? That seems like it's a larger number than it would have to be, because there's no more than 5. You look at there are no more than 5 options for each factor. Well, that is true, but what I've done here is said, modify this. And notice it's got to come up. So here are the factors with their potential options. Let's see if I can make that a little bigger. Yeah, you can see them there. And again, that's just you add the parameters one by one with their possible values. Now, the thing I've also done here, though, is I said, hey, for Wi-Fi connection, Wi-Fi frequency, and Wi-Fi calling, I want the strength of 3. I want the triples on that, not just the pairs. Okay, so that's something you can do. If there's some particular set of parameters, you're like, yeah, those guys really worry me. I want to make sure that I've tested all the ways that those can interact. Then I can do that. All right. Now, there's also a way of doing constraints. So I can say this thing, this parameter or this factor, if it takes on this particular value or option, this other thing can't take on that option. And notice that I have one of those here. I've got a constraint. Let's see if I can get this expanded out. Yeah. Okay. So this constraint is saying if Wi-Fi connection equals no connect, or if Wi-Fi connection equals off, then just set the Wi-Fi frequency to be 2.4. And this is why we have 28 rows in the table rather than 40 rows in the table, because if we go back to the problem, we have 1, 2, 3, 4 possible values for a Wi-Fi connection, 1, 2, 3, 4, 5 for Wi-Fi frequency, and 2 for Wi-Fi calling. So 2 times 5 times 4 would be 40. So theoretically, there would be 40 rows in the table. But because if the Wi-Fi connection is off, or the Wi-Fi connection is, there's no connection, then we're not going to try to do a bunch of combinations with that, because obviously there's nothing interesting happening with the Wi-Fi signal in either case. Now, the constraint editor is pretty powerful, but it's not all that well described in the documentation. I would encourage you to just get it, put on your big boy or big girl pants, and do a little experimentation with it. It'll take a while to figure it out, but not all that long. Generally speaking, when people start playing around with it, they get a pretty good sense of it in the space of a few hours. I'm not going to bother to save that. So that's the Axe tool. A nice little piece of free stuff from your friendly neighborhood federal government. So I'm going to go ahead and put the advertisement up. If any of you have any questions, really don't have a whole lot to add to what I showed you, other than, if for more information, go out to pairwise.org and navigate either to the Axe page on the NIST.gov website or the PICT page. Again, I've used both of those tools. They're free, and they're very quick. They're no bells and whistles, but they, as I said, they are free. And quite powerful. So I think they're good value for what they are. I got a question from Julio here. It says, when trying to test that bigger amount of combinations, when trying to test a bigger amount of combinations, won't that stop making sense manually, is the implication, and only some kind of automation is the right approach? All right, so Julio, yeah, it's true that one can, with automation, test a larger number of combinations. But let me warn you of something, because this is a trap that some of my clients that I work with, actually a number of my clients that I work with on automation, fall into, and this is seeing the automation as a bucket of infinite size and speed. And what I mean by that is infinite size implying I can put as many tests in there as I want and run them, because they run for free. And the infinite speed meaning I can put as many tests in there as I want and run them, because they'll all run overnight anyway. Both of those assumptions are fallacious. Automation dramatically reduces the cost to run a test, but it does not take it to zero. So you still have a greater than zero cost associated with running a test. And so the bucket is not of infinite size. You have to think about what actually belongs in the bucket. And it's not of infinite speed either. Even though automated tests can run very fast, they do not run infinitely fast. And eventually what will happen if you take a brute force to test design and just start automating the hell out of everything that comes along, is you will run out of space in your bucket. And sometimes what organizations will do is, no problem, we'll just spin up another virtual machine and we'll run, half of the bucket on one and half of the bucket on the other. But, well, yep, but then eventually there's another virtual machine and another virtual machine, and guess what? Now your cost per test is going up because you're adding more hardware resource. So test design techniques still matter. They still matter when you're doing automation. You still want to do an effective and efficient set of tests, not just think, well, I've got this big, powerful tool, this automation tool, I'm just going to use it to just bang the hell out of everything I can. So great question, Julio. Hope that was a useful answer. Now I see somebody popped up in the chat box with regard to something earlier, with regard to the orthogonal array. Let's go back to that. It's this one. Now, generally, I don't look at the chat box, so just something to warn you about. You will usually I won't see this, but I did see this one from Brian. Brian, next time try to drop that into the QA box, if you will. We'll get this one last question and wrap it up because we're running a little long. Brian asks, what about 111 with regard to this particular table? Well, remember, we're not guaranteeing all possible triples or quadruples or quintuples or so forth. There's nothing beyond triples on this table. We're just guaranteeing pairs. So when you ask, what about 111, then the answer is, I don't care if 111 is in there. But what I care is that 1 and 1 for factors 1 and 2 are there, 1 and 1 for factors 2 and 3 are there, and 1 and 1 for factors 1 and 3 are there. Those are all the possible pairs of 1 with 1 across the possible pairs of factors, 1 with 2, 1 with 3, and 2 with 3. And those are all there, albeit in different rows. So hopefully that addressed the question with that. All right, whoops. That wasn't supposed to happen. Yeah, there we go. So put the ad back up while we roll this thing to a close. Again, I hope you enjoyed this free webinar, part of the monthly series. Got 2 for this month. Now, just a reminder, we do these webinars, these free webinars, as a service to the software testing community, because at RBCS we are a not just for profit company. But keep in mind, that's not just for profit. We do need to make a profit, or at least break even. And during these challenging times, I would appreciate you keeping this thought in mind. If you enjoy our free webinars and all the other free stuff, the hundreds of free resources that we give away on various RBCS resources like the ones you see here, and you feel that those resources demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training related to software testing. We don't expect to win all your business, but we would very much appreciate a chance to bid on all of your business that relates to this. Now more than ever, this is particularly important as we're all going through this tough time. So if you're looking for some help with regard to software testing, please give us a chance to bid on it. Happy to provide a quote for any such help you might need. So contact us, info@rbcs-us.com. And until next time, stay safe, stay healthy. Try not to catch the sniffles or worse from any bats that might come flying by.